Welcome to Study Loop.
So in this problem, we are given an ideal gas that is going through idealized process. We have two processes. We have the first process is going to just increase the pressure, and that's it. It will not change volume in any way. And then the second process will change the volume, but it will leave the pressure at a constant value. So we will use the color green to sketch the first process. So this is going to be just the volume V1, that is the starting volume, and we have just a straight line like this, because okay, maybe it is not starting from zero, it is not, we know that from the problem, so it is starting from a certain pressure to a certain pressure, so it will look more like this, and it's going from the starting point to some ending point of that process. This is the first process, and this is the direction of the process, is going like this. Now, for the second process, we will use the color red, and here we have change in the volume, but we have a constant pressure. This is P2. Of course, the starting pressure was P1. And only the volume changes, so it is going to be a perfect straight line like this to the volume V2. And the direction of the process is given by this arrow. So this is pretty idealized, and these kind of processes are not always possible, like to be exactly like this on the diagram, but for this problem, this is the solution of the part A of this problem. Now, for the part B, we need to find the work done. And the work done is going to be a sum of two works, two processes. So each process has some work that is corresponding to it. For the first process, the work V1 is simply going to be equal to 0. Now why? Well, because in the start there is no change in volume. Remember the law of work. I mean, the definition of work is going to be an integral from V1 to V2, P as a function of V times differential of the volume. So if V1 simply equals to V2, therefore the work will be equal to 0. And that is exactly why this part is going to be 0. Now, the work V2, here we can say that the compression is being done. It was already done, so the pressure is now P2. But the volumes are changing. It is going from volume V1 to the volume V2. And in this case, there will be some work done. But remember that the pressure is not changing with the volume. The pressure is being constant, so we can simply immediately put it this way: P2, this is the final pressure, times V2 minus V1. And this is going to be the relation for the second part, work corresponding to the second process. So if we substitute the known value, this is going to be 5 times 10 to the power of 5 pascals, this is the unit for pressure, times, in the brackets we're going to have this change in volumes, which is going to be 0.12 meters cubed minus 0.2 meters cubed. And obviously the result will be negative, so this work here is going to be negative, which is logical since we're doing compression, we're decreasing the volume, so this will be equal minus 4 times 10 to the power of 4, and it's going to be in joules, which is the elementary unit for the work done. And the final work is going to be equal to work for the first process and the work for the second process, which is equal to 0 plus negative 4 times 10 to the fourth joules, and finally this equals just minus 4 times 10 to the fourth joules. And with this part we have solved the problem as incomplete. I hope this was helpful, and I hope to see you in the next lesson.